Now here we have a question which says green colored nickel PPh2Et2 Br2. So this is a complex which has two kinds of ligands. One is ethyl diphenyl phosphine PPh2Et and bromo ligand. Okay. So it has a magnetic moment of 3.2 bm. The geometry and the number of isomers possible for the complex respectively are. So we have four options where we have to find out the geometry of the complex and the number of possible isomers. So how we approach this problem? So we have what we have in the question. So we have the magnetic moment which is given and we have the complex. So magnetic moment of this complex, we can find out from this magnetic moment the number of unpaired electrons applying the spin only formula. So the magnetic moment given is 3.2 Bohr magnetons and the spin only formula for magnetic moment is under root n into n plus 2, where n is the number of unpaired electrons. So we apply this formula and get n. So n is almost equal to 2. So we have 2 unpaired electrons. And what is the oxidation state of nickel here? So nickel is PPh2Et2. This ligand is uncharged. So we have X plus 0 and bromo is minus 1 charge and we have 2 bromo. So minus 2. Total charge is 0. So X is equal to plus 2. So nickel is plus 2 oxidized. Now in the plus 2 oxidation state, what is the valence electronic configuration of nickel? So it is 3d8 and there are no electrons in 4s orbitals, 4s 0. So now we try to fill this d8 electrons. And before filling these d8 electrons, we have to understand the nature of our ligands in the complex. So both of these ligands, the PPh2Et, ethylene diphenyl phosphine and the bromo ligands, both are weak field ligands. Okay. And we know that weak field ligands, they do not encourage pairing. And so the d8 electrons, now we know that there won't be any pairing of the inner d electrons. So now we try to write the electronic configuration, valence electronic configuration for this complex. So we fill the d electrons, the 8 d electrons. So the 3d orbitals are occupied singly first and then pairing occurs like this. So 5, 6, 7 and 8. Okay. And then how many electrons are contributed by the ligands? So we have 2 PPh2 ligands and 2 bromo ligands. Okay. So one ligand contributes 2 electrons. So 2 into 2, 4 from bromo and 4 electrons from PPh2Et. Okay, so total how many electrons from the ligands? 8 electrons. Now we have to accommodate these 8 electrons in the 4s and 4p orbitals. So this is how we accommodate 2 in the 4s and 6 in the 4p orbitals. So total 8 electrons from the ligands. And now what kind of hybridization? So this is sp3. Inner d orbitals are not utilized for hybridization and we have sp3 hybridization, which corresponds to tetrahedral geometry. So we got the answer of the first part of the question. So it is asked what is the geometry. So the geometry of this complex will be tetrahedral. And now what should be the number of isomers? So tetrahedral won't give you any isomers here. So if we make it in a square planar form, then we get the 2 isomers. So here I would like to mention that from the scientific data available for this compound, it has 2 types of crystals, the green colored and the red colored. The green colored crystals are the ones that is given in the question, which has a tetrahedral geometry. Okay, while there are the red color crystals also, which have square planar geometry. That means square planar geometry exists for this complex, and that is why it can have two isomers that we will see now. And that is the second part of the questions, that what are the number of isomers. So the isomers are not coming from the tetrahedral geometry but from the square planar geometry, which are part of the red crystals of the same complex. So if we imagine this as the isomers of the type, so we have two different ligands. So central metal ion is nickel, and then we have A2B2, Ma2B2, two different ligands which are repeated two times, Ma2B2. So if you remember isomerism in coordination complexes, how can we arrange these ligands in the square planar form? So Ma2B2 type of complexes, we arrange, one of the type is where we arrange these similar ligands on one side, okay, which forms the cis isomer, and the similar ligands on the opposite side, which forms the trans isomer. So cis and trans. So two types of isomers are possible for this kind of Ma2B2 type of complexes. Okay, so the second part of the answer will be not 1 but 2. So finally the fourth option will be the correct answer. So hope this explanation is clear and hope it helps. Thank you.